So again, the HDL is called slang good cholesterol. This will bring cholesterol back to your liver. And notice cholesterol is being pumped back to your liver here. LDL is considered bad cholesterol. It takes the cholesterol and puts it into your peripheral tissues and into your arteries where they can build up and aggregate. And so if somebody has an imbalance in low-density lipoproteins and high-density lipoproteins, you may start pushing too much cholesterol into the peripheral tissues and arteries, and not enough is being removed. Whereas if someone has a lot of good cholesterol, they're removing it. So the important take-home here is that cholesterol is just cholesterol. When someone says good or bad, they're talking about the protein which is shuttling the cholesterol. And good cholesterol removes it from your arteries and tissues and brings it back to your liver. And bad cholesterol takes it from your liver and puts it back in your body where it can do some damage. Biological membranes. Here we have semi-permeable cellular barriers that exclude dangerous chemicals from the cell while allowing nutrients to enter. And here we have a lipid bilayer. Just like we saw with the liposome, the fatty acids orientate themselves so that the hydrophilic phosphate groups are touching the water, leaving a lipid barrier in between. And that lipid barrier is super useful because almost nothing can just cross it without help. So the only things that can cross it like it's not there are extremely fat-soluble molecules like steroidal hormones or nonpolar tiny molecules like oxygen and carbon dioxide. And so basically, oxygen, carbon dioxide, and the real fat-soluble steroid hormones move through the plasma membrane as if it wasn't even there. Everything else needs a special protein to get in, and that is called facilitated diffusion, because things are still flowing down their concentration gradient, but they need to be facilitated by a protein, which can be a carrier or a channel to get them through. If you need to use energy to pump something uphill, now we call that active transport. So again, a few molecules move through by simple diffusion. They just diffuse through the plasma membrane as if the plasma membrane wasn't even there. And that's oxygen, carbon dioxide, because they're both small nonpolar molecules. And then the really fat-soluble molecules like steroidal hormones. For all the other molecules, they can move through, but they have to go through a specific pore or channel. Even water moves through aquaporins. Every other molecule needs a specific protein to get access into the cell or out of the cell, and so we call that facilitated diffusion when it's moving down its concentration gradient. And if you're inputting energy to pump something up its concentration gradient, we're going to label that as active transport. The fluid mosaic model. Here we have a membrane with random pattern of proteins. It's about, the cell membrane is about 60% protein, 25% phospholipids, 10% cholesterol, and 5% sphingolipid. So what statement best describes the composition of a biological membrane? Hydrophilic outside, hydrophobic inside, giving you that barrier. The fluid mosaic model also states that it's very fluid. Things are free to move around all over. And we do studies with lasers. We bleach areas and see how long it takes things to move around. It's a very dynamic system. Things are moving around all the time. And that is the end of the lipids chapter.